Before we start, we have something to share. So we have a live stream link on our Facebook. So if you can, please tweet, like, comment, subscribe to our YouTube channel, and tweet out our live stream link. So I think we still have a couple of guys haven't been here, so let's start with a joke. So, how would a YouTuber's kids say goodnight to their parents in 2017? Anyone? The answer is like, comment,
like and subscribe.
Yeah, that's right. Please like, comment, and subscribe, because their parents say it too much. So too often they thought it's goodbye and good night. So if you do, please.
Okay. So this is not a nothing special. This the pineapple cake from Taiwan is called Sunny Hill. Yeah. So I myself think this might be your favorite things to take back. Yeah.
Only one back.
What?
To all of them?
Yeah.
We can share.
Yeah, you can share. Yeah. There are 10 cakes inside, so feel free to eat it. Okay.
Thank you very much, and thank you for having us here tonight. It's a pleasure to talk.
Yeah, thank you. I think we can have a photo shot, right?
Yeah.
All right, okay. So,
Cheers.
Are we done?
not yet. Yeah.
Okay.
Yeah, okay.
Skip the agenda.
需要
人
记得这样。
Okay, thank you.
All right, let's welcome our first speaker.
So we use the slides.
So Robert, for the overview of Polkadot.
Yeah, but we changed it. Yeah. Alan has a very old laptop.
It's a classic. It's for finance.
Yeah. This is a microphone, so yeah, perfect. Yeah, and that works too, right? Cool. So hello everybody. My name is Robert Habermeier. I work at a company called Parity Technologies. You might have heard of us if you're deep into the Ethereum space, for example, or the Bitcoin space that we've written an Ethereum node and a Bitcoin node and a whole bunch of other stuff in this space. Right now we're also working on researching and developing Polkadot, so that's what I'm going to talk about today. So without further ado, I want to talk about sort of our motivations for why Polkadot should exist. So the 5 key failures of current blockchain technology. So first we have scalability. I think this one is on everybody's mind a lot of the time. How many transactions per second can actually be processed? How much work the network can really do. We also have stuff like applicability, whether this network can really solve somebody's problem. Governance, whether that network can be modified over time, whether it can adapt to changes, new research, new code that's been written, new methods. Isolatability, so the ability of the network to solve multiple people's problems, to be useful for more than one thing at a time. And lastly, I think, which is often overlooked, is developability. So whether developers can actually build on top of it, whether the tools are there, whether it's convenient to use. So Polkadot answers these in three key ways. So we have first and foremost, extensibility. So Polkadot is a fully extensible network. It's a blockchain where you can extend its functionality with arbitrary Turing-complete, what we call parachains. I'll dive into that a bit more later. Heterogeneity, so those parachains can each be completely different from each other. And also scalability, so we can execute these parachains, parallelizable chains, in parallel with the same amount of security. And also, these parachains could implement scalability primitives themselves, things like state channels, off-chain computation, all those other things you've heard about, and new things that nobody's heard about yet at all. So, to talk a bit about the current approach of how blockchain projects come together, we have varying degrees of generality over potential applications in existing blockchains. So there is no blockchain that's really right now actually suitable to an arbitrary project. They have certain functionalities built in that if your project uses those functionalities can be implemented, but if not, you're mostly out of luck. So we split up the concept of a blockchain into two parts. So you have the state transition mechanism, so that would be how the transactions work, what the state is, account balances, smart contracts, privacy, things like that. What state is actually changed by the transactions in a block. And then there's the second aspect, which is the consensus, canonicalization, finality, replication engine, whatever you want to call it, which essentially provides security for that state transition mechanism, and furthermore allows people to come to a consistent view of history. So if I ask somebody on this side of the room and somebody on that side of the room, they can both agree on exactly what order events occurred, which events occurred, and come to a consistent view of the state of the system. So the Polkadot approach is a little bit different. So we have a relay chain, which provides pooled security and passes messages between the parachains, which contain logic and handle transactions. So we have essentially a very general state machine, which allows for other blockchains to be attached to it and to have messages pass between them. These other blockchains aren't providing their own security, they're instead drawing from the security of that relay chain. So the mode of consensus we're using for the relay chain is proof of stake. That's something we're doing research into right now. But parachains themselves could just contain some method of checking validity of a parachain candidate block. And the result is that we have what you could call a Polkadot pick and mix. So you can have parachains that look like Bitcoin, like Ethereum, like Zcash or Monero, or fulfill some other kind of purpose, another kind of smart contract, stuff that hasn't been thought of yet, specialized chains for consortiums, whatever. You can plug it all in, more or less. If you can write it, you can plug it in essentially. And that's a pretty powerful tool for sure. And again, what it provides is pooled security, guaranteed security for all of those attached chains, and also, furthermore, messages to be passed seamlessly between them. And those messages are just arbitrary data, but it allows you to build applications that leverage properties of those chains. So each of those chains would implement some kind of functionality optimally for its niche, essentially. They're probably going to be fairly targeted, fairly focused chains that do whatever they do efficiently and they do it well. And you can have applications that use each part of those, whichever they require, and sends messages between them in order to leverage those different chains together. So the benefit of pooled security is that projects aren't competing with each other over security resources, because there's only this finite, I guess, there's an existing amount of security resources, people who are willing to put down their computation or their disk space or their time or their money down in proof of stake to provide security for blockchain projects. And right now, projects have to compete with each other over those security resources, and oftentimes they may have more security provided to them than the value of that network actually requires. So you could think of that as blockchains sort of squandering their security resources. And with pooled security, then each project has exactly as much security as it needs, because there's this big, essentially, pool of security that they can draw from. So one really cool thing that enables is public and open chains to be integrated seamlessly with private permission consortium chains, whatever you call it. And what we've seen historically is that enterprises are very hesitant to come into the public blockchain space. So they don't want to build something on public open networks because they're often afraid that they don't have enough control over the data. But if you can allow a bridge between them, and this is something that Marek's going to talk about a bit later, exactly what the details of that bridge might look like, then you can allow those public chains to draw information from the private chains, or vice versa. But the consortium chains, the private chains, still have full control over the data that they provide. So now I would get into, I guess, what we call the nitty-gritty, sort of more technical details, now that we have an idea of what the motivation is, sort of the mechanisms that we're aiming to provide. So first of all, some of you, if you picked through the paper, you might have seen this diagram before. So that's essentially the relay chain. So we have this relay chain. In the center here, we have validators who are performing proof of stake, and we have parachains attached to it. So there are a few different kinds of parachains, which I'll talk about, but I'll get to that a bit later. First, I want to talk a bit about the roles. So who powers this network? So first of all, we have validators. So validators are essentially performing the act of creating blocks, and they put down a security deposit so that if they misbehave in that act of creating blocks, they can be punished, and that security deposit will be forfeit. Nominators select good validators and increase economic security. So there is a reason that nominators exist, and it's not just have everybody be validators. And the reason is that in a consensus process, the more, the amount of communication that is required to reach consensus grows faster than the number of parties who are attempting to achieve consensus. So that communication cost grows with the square, essentially. So if you have 5 people trying to reach consensus, you might have on the order of 25 messages. So the security of a proof of stake network, however, depends on what proportion of the staking tokens are locked up. So we want to maximize this proportion of staking tokens which are locked up, while minimizing the amount of people who actually have to reach consensus between each other. So that's the purpose of splitting validators and nominators. So nominators are essentially finding a validator that they believe will do work correctly and vouching for them. So they say, I will put my money down that this guy does his job well. So we also have a couple different roles which are in a different vein entirely. So we have collators. So each collator just picks a parachain, and they are collecting unmined, unsealed, unincluded transactions on that parachain. So you can have one collator on parachain A and one collator on parachain B, and essentially for every block they're sort of making what we call a parachain candidate. So a parachain candidate would be the sub-block for a parachain that then get combined, all those parachain candidates, into the main Polkadot relay chain block. So we have collators who prepare those candidates and also proofs of validity. So they prove somehow, it could be a zero knowledge, a non-interactive proof, it could be just an interactive Merkle tree proof, like for example, that's what you would do with Ethereum now. And that's so that if a bad parachain candidate is included, somebody can prove that it's invalid. And that's what the fishermen do, basically. So they keep a watchful eye that validators behave correctly. If a validator includes a parachain candidate block without a proper proof of validity associated to it, then that fisherman can create a proof of misbehavior and lead to that validator being punished. So again, we have, well actually I'll go here first. So we have a few different roles. So you can see here, these little triangles, those are the validators. And each validator is assigned to a different parachain. So they're colored differently. I don't know if it shows up that well on the screen. But we have some validators on the purple chain, we have some validators on the green chain, and every block that's different. And we actually do this, it's not strictly speaking necessary, but we do it as a mode of scalability. So the idea is if you have 5 parachains, you can split up the validators between them. And then you have the fishermen who are watching for misbehavior, and that will create a game theoretic equilibrium that the validators have to behave correctly. So for the same amount of work being done by the validators, you can have, say, 5 times the throughput. But then if we look closer at this parachain, you can see that there are collators living on that parachain. There are collating transactions that are being propagated on that parachain's subnetwork. And you also have fishermen who are watching for misbehavior, who are watching for validators that are including bad parachain candidates for that block, or for that parachain. And if we want to talk a bit about different kinds of parachains, we can split them up pretty easily into 3 categories. So we have open parachains. So an open parachain just defines a validity function, essentially. It says, give me a block, give me a proof, and I will tell you true or false. True if it's valid, false if it's not. So that's the easiest way to write a parachain. You can also have a closed parachain, which is slightly different than an open parachain, semantically speaking, although technically they're actually the same. So the closed parachain can have any kind of state transition system it wants, but it's just got a validity function that checks whether the block was signed by one of the right group of people, for example. And that lets you integrate things like consortium chains. Because in this case, it doesn't matter whether the state transition was maybe, strictly speaking, always according to some kind of open known rules, or even if there's known transactions that are happening on that chain, all that matters is if someone signed on that closed chain, like a trusted party was signed on that closed chain. Because again, that closed chain belongs to some private or consortium network that just wants to interface with the public parts of the network. And lastly, we have bridge chains. So there are already blockchains out there. So the Ethereum network exists. The Bitcoin network exists. Zcash network exists. And when we launch Polkadot, we don't want to just throw out all that progress. There's already state on those chains. There's already accounts on those chains, smart contracts that we don't want to lose. So you can write bridges, essentially, that act like a parachain, but really it's just a stub. And it pretends to be this other chain when really it's forwarding messages back and forth between the other chain, some other blockchain that provides its own security. And Marek's going to talk a bit about the implementation details of a bridge between Ethereum chains, so how that might look. And again, we can see a couple different kinds of parachains here. So actually, these two are the same kind. They're probably just open or closed chains. You can't really tell there. But they're directly integrated into Polkadot. This one's zoomed in so you can see the roles. That's a bridge. So you see it's sort of, there's a gap between the actual Ethereum network, it's a virtual parachain, and the relay chain, but there's this bridge that lets you ferry messages between it. And the last one is one I want to talk a bit more about. So that's one method we have for scalability, which is this idea of having parachains attached to the relay chain. And this parachain would have its own child parachains attached to it. And this idea of creating a tree of blockchains where you can fragment computations down the leaves and collect the results back could be a very viable route towards scalability. Because if you think about it, the relay chain just has to process one parachain candidate from this block. But that parachain candidate from this parachain could include the accumulation of hundreds of others further down that tree. And that's a very powerful tool and something that's definitely, that we're definitely looking into. The hardest part is things like latency or ensuring security or ensuring that proofs of validity stay available even the further you go down that tree. But if those things were possible, you could reach a very, very high degree of scalability in the computation that blockchains can perform. So why do these participants actually bother doing their jobs? So very often you'll be presented with some kind of system and people will say, if the majority or 2/3 plus 1 are honest in this system, then everything is going to work. But that's not really enough, is it? Because we're interested in how rational actors behave, how those who are pursuing the maximum gain for themselves will act. So the validators and nominators are rewarded for doing their jobs by staking token expansion. So they've staked some tokens on correct behavior, and if they do that correct behavior, then they receive some new tokens that were just created, for example. That's how proof of stake works in general. And if they misbehave, those tokens that they put down would be forfeited. Collators are collecting parachain specific transaction fees. So this could vary from parachain to parachain, but they have some kind of, when you integrate a parachain, you should be providing some incentive for people to actually collate transactions or produce parachain candidates for that chain that you've added to the Polkadot network. And the fishermen are the hardest to reason about incentivization for. So the fishermen are watching for misbehavior of validators. But if you think about it, if fishermen exist, then nobody will misbehave. If nobody misbehaves, then there's no incentive for fishermen to exist. And you get this sort of circular problem that a lot of people realize you have to find a way around. So, of course, fishermen receive a proportion of the staked tokens of the validator that they found misbehaving. So they get a kind of finder's fee. But if there's no misbehavior, the expected value of that would still be 0. So there are a couple ways you can sort of think about this. One option would be to actually periodically force validators to misbehave and essentially provide a lower bound on the amount of value fishermen could expect to receive. You could also think about the fact that being a fisherman requires almost 0 effort. So if you're running a node, you would have barely any additional cost to being a fisherman. The only additional cost being the fact that this node has to be able to automatically sign messages on behalf of some account and put down some security deposit for the fraud proofs that they're putting forward. But it's actually fairly negligible. And the fact that there only needs to be 1 fisherman per parachain for the system to actually function. So we have to find some incentivization mechanism that works, but it could be, I mean, if we've looked at, say, the BitTorrent network or Whisper, you can see that people are just running full nodes out of the goodness of their heart. So I don't know exactly if you can quantify that, but it may be enough. If not, then we can put in a concrete system that actually establishes a known lower bound on the value that fishermen have for participating. The important thing is to create this equilibrium. As far as achieving consensus goes, we are implementing a proof of stake system. So again, people put down staking tokens and in exchange for the ability to mint blocks. If they misbehave, then that security bond is burned. We also have this notion of economic finality. So it's essentially a set of economic incentives that once a block has been created, and a certain amount of blocks have been built over it, or you have a certain number of attestations from other validators, that this block would never be reverted without leading to a significant loss of funds in all histories branching off from a certain point. So that's a pretty interesting prospect because it also creates an equilibrium that blocks would never be reverted. And for example, in a proof of work system, you can only have a probabilistic finality, whereas assuming actors are rational in a proof of stake system, you can actually have a more or less guaranteed finality. And that's very important for being able to pass messages between bridged chains, for example. And of course, we have these parallel validation groups where the validators are partitioned amongst different chains in order to scale, I guess, horizontally. As far as governance goes, we want it to be stakeholder driven. So stakeholders would hold votes, perhaps on-chain, over whether to include a new parachain or not. So things like that, other governance related votes should be controlled by the stakeholders. We could go for some kind of bicameral, that's two houses, inspired governance system that's inspired by modern forms of governance. We have to look into that. There are a lot of options we have, but the core thing is that we want it to be stakeholder driven. And we also want it to be community focused so that there are means for aspiring projects to acquire resources for what they're trying to build. So one idea we have for that, not necessarily a sure thing, is that a portion of the block rewards could be put into some kind of DAO, a distributed autonomous organization that's also maybe stakeholder driven and used to give out funds to projects who are going to build something useful to the Polkadot network. As far as development goes, what we're building right now is we're expanding our what we call proof of authority consensus. So proof of authority would be where you have a known set of people who are allowed to issue blocks. So you have people A, B, C, D, and E. They're allowed to issue blocks. The way it works in Parity is that they have to take turns. And that's a permissioned system. So right now it's mostly used for enterprise, private, and consortium networks. But we're extending it with misbehavior reporting and dynamic validator sets. So you can choose dynamically by a smart contract who is allowed to mint blocks. So at block 100, you could have an entirely different set of people minting blocks than at block 50. Or at block 100,000, it would be entirely different. And you can code that up in a smart contract. With the combination of misbehavior reporting, that's enough to build a simple proof of stake system. We're also integrating light client support. So I mentioned these proofs of validity before. So the proofs of validity that we have for parachain blocks will also allow a light client on the parachain, or on the relay chain, to acquire information securely about any parachain which is attached to the Polkadot network. And we're very keen on having light client support in Polkadot because we've seen that the costs of running a full node are astronomically high and they're only growing. So it's beyond the reach of average people to run a full node on their laptop anymore, one that's constantly synced. So you have to have light clients. And light clients have a very slightly smaller security proposition, but if you trust the consensus and you trust that the parties are behaving with those economic incentives that you can verify from a light client, then it's just about fine to use. Of course, if your use case has very high value, then you should consider strongly whether a light client is for you. Bridging Ethereum-like chains. So Marek's been working on that for a while. He's going to talk about that shortly, exactly how that's going to work, the technical details. And it's frozen. So I can talk about the other two things anyway. So we're also working on expanding the set of peer-to-peer networking tools that we have. So right now we have a lot of different participants of the Polkadot network. So we have the collators, the validators, the nominators, the fishermen. We have people propagating transactions and creating them. So that actually requires a very strong suite of peer-to-peer networking tools. So right now we're working with modifying Dev P2P, which is the library for Ethereum peer-to-peer communication. But we're looking into building lib P2P, which is what's used by the IPFS project. It's designed by Protocol Labs, and we're looking into building that and building systems on that for complex peer routing and forwarding of messages and things like that in order to develop the POC of Polkadot on top of. And what was that other thing? Oh, been signed out. Gigi, you have the password. Okay.
How do you're broadcasting live right now, by the way? Yeah, good. Let's password. Can I open on your laptop? You need to plug it in now. Okay.
Do you know this password?
I'm not gonna play it now. I haven't though.
You need to turn the projection off.
Yeah. And live stream. 2 seconds. Is it shared with
I'll
me as
just
well?
turn the projector.
Okay.
It shouldn't.
I believe it's shared with me as well. There's a new one?
Well, in the meantime, we can start. I mean, we were just about wrapping up, but we could sort of start to
Q&A?
freewheel a bit, do a bit of Q&A. If you guys have any questions, yeah,
Couple, I'll only ask one until we run out.
yeah.
So can parachains inherit security attacks from other parachains?
Yeah. So parachains inherit their security from the relay chain, or for example, if they were attached to another parachain, if it's deeper than one level deep in the tree of parachains, then it could inherit security attacks from any level above that. So if somebody, for example, found a way to overwhelm the proof of stake security of the relay chain, or found a flaw in the implementation of the parent parachain of that chain, then yeah, it could also be compromised. Yeah. I mean, if there is a certain amount of stake on the network and you put down even more money, you have essentially bought the function of the network for the time being, at least until someone maybe overwhelms you back. So at that point, you can kind of do whatever you like, or censorship. You can't actually force invalid state transitions, but you could also grind the network to a halt. Yeah.
What the parachain like IOTA network, which is not a blockchain, so it means it will not have a global state. How do you verify transaction?
Could you repeat that? Sorry.
I mean, what is the parachain? It's not like a blockchain, which is like, for example, it's like an IOTA application. So how do you verify a transaction which do not have a global state?
Yeah. So, I guess specifically you're referring to the DAG model of decentralized networks. So the thing is, actually, I would say you have to have some kind of state transition that's, you're at start state A and you progress to state B, and you have to have some kind of transition that is going to get you from A to B to be included as a parachain. Something like IOTA, I'm not sure. Well, at least under the current model with the coordinator, I think it could be possible. The idea of a DAG in general is not conducive to being added as a parachain, although that's only for DAGs, in a very abstract sense, because blockchains right now are DAGs. Like, you just have a DAG, people can make forks, that's a DAG. That's a directed acyclic graph. You just have a fork choice rule that allows people to see a consistent view of history of what's happened before what else. Yeah.
I've got a question about, I'm an investor basically, and I'm looking at your ICO now. I'm just trying to get an idea of, like, you've raised, how many Ethereum have you? You've raised about 120 million.
So I'm actually not personally involved with the sales, so I'm just working on research basically.
Oh, okay.
But I suppose, Gigi, you could answer that?
Yeah.
I mean, what's the rest? It seems like a strange ICO because the way it's structured, I don't quite get it.
Yeah, if you want to talk to me about that after, I think that would be the presentation focus on technology in general. We're not.
I see, okay.
Yeah, but I'm happy to catch up after. We can chat about it.
Sure.
Can you talk
And
can you talk about the difference between Cosmos?
Yeah, so there are a few primary differences between Polkadot and Cosmos. So the first being that Polkadot has this notion of pooled security, whereas Cosmos splits up chains into hubs, and each hub splits up chains into zones. Each zone provides its own security. They're each running their own Tendermint process, proof of stake, and also transferring tokens between them. Whereas Polkadot is more about security flowing from a root and passing arbitrary data. So data being just bytes, you could, for example, represent a token transfer in bytes, but it can be used for much more than that as well. For example, passing some other message that triggers a call in a smart contract on another chain, things like that.
And in terms of scalability, I read somewhere that since all the security is kind of on the zones for Cosmos, and if they want to fork, it's easier. Where Polkadot wants to do an upgrade to the relay chain, it's a little more complicated. Since is that true?
Yeah. So I mean, the fairest comparison between a zone in the lingo of Polkadot would be with a parachain, right? So the way you would usually perform a parachain protocol upgrade on Polkadot would be actually to add another parachain that, you keep the old one with the old rules, and you add another one that sort of has the new rules at a certain block, and you just wait for one to die off and be removed by the stake. So that can actually be done dynamically. Whereas, as far as governance goes, you can have, it's a spectrum. So for example, you can encode all the rules of operation on the chain. And you can say, well, the actual consensus logic, everything, whether it's proof of stake or proof of work or all of that, will be completely configurable. And Polkadot does not go that far. So if we want to change, for example, how the proof of stake works, how parachains are added and removed, this would have to be done with a hard fork of the relay chain, that's true. So it has this social governance layer as far as that's concerned.
Is there any fairness poker design into the relation?
If there's any
Fairness poker design. Fairness. No, because you need to process the
fairness of
design into a relation, because you need to handle the different transactions from different parachains. So what's the biology, or how do you tell?
So fairness between parachains. Whether parachains
the mechanism into the relay chain.
The transactions in the relay chain, whether there's fairness.
Yes.
So the way we have it structured right now is that each relay chain block would contain at most one candidate from each parachain, but we try to include a candidate in each parachain, from each parachain in the relay chain block. So there are validators who are assigned to each parachain, and they are meant to either get a candidate from a collator or produce none. But they would be incentivized to do this, to accept a parachain candidate from the collator. So for example, well, I really don't know actually what you mean by fairness. Who would be treated unfairly in this situation?
For example, if there are maybe 4 or 5 parachains who want to submit a transaction to another chain, so how do you process this kind of block that when you receive?
Yeah, so specifically this would be like the message queues between parachains. So the way that works is we have to do some kind of spam protection. So people will probably have to pay for the privilege of sending a message to another chain. And furthermore, messages will not be processed when the queue of the receiving parachain is full. So that message would be essentially delayed until that queue has drained enough for it to accept the message. So it's unlikely that messages would be relayed between parachains immediately. It's rather meant to be asynchronous. So the asynchronicity means that messages between parachains are being processed as fast as possible, but they aren't promised to be processed instantly. Great, yeah. So to finish that up, the last thing we're working on in development right now is this generalization over state machines and Parity. So in the Parity blockchain node codebase, we have this notion of pluggable consensus. So you can sort of choose what consensus algorithm in the internal architecture that you're running with. So that could be some kind of development consensus that isn't really consensus at all, but it's for running a local development chain. It could be different kinds of proof of work. It could be proof of authority, and again, kind of maybe proof of stake with that extended proof of authority. Right now we have Tendermint implemented as well. But then we also have this generalization of state machines. So those consensus engines themselves, you could plug in something that looks like Ethereum or something that looks like Bitcoin. And we hope that this eventually will evolve into a set of developer tools for people to build parachains using Parity. So that consensus engine that you're plugging the state machine into could itself just be relay chain consensus. And you could write it like that. So if you want to follow the progress, right now most of the development is happening at ParityTech/Parity. We also have some private research channels basically where we're shooting ideas around, and we have the paper obviously. There's a chat room about the paper at this Gitter site here. And if you want to learn a bit more about the tech, it's at Polkadot.io.
We're a bit late on schedule, so let's welcome our next speaker. We'll take a break after the next talk.
Yeah, let's just use the arrows.
Oh, like this.
Okay, so my presentation will be slightly shorter, so I think we'll get back on schedule. So I'm Marek Kotewicz. I'm one of the core developers of Parity. Before working for Parity, I was working on the Ethereum protocol since 2014 for Ethereum Foundation, and I've joined Parity at late 2015. So Rob introduced us to Polkadot. So the key components of Polkadot that are in development are WAS and backend. So we want to run our smart contracts in WAS, write them in anything like compatible to WebAssembly. There is Bridge, which I'll be talking about. Lifetime Proof, Superstar, Consensus, and many others. So today we'll focus on the bridge. So what's the bridge and what's the goal for that we want to achieve? So basically we want to connect any two Ethereum-like chains with a secure relay layer that will allow them to interact with each other. So let's say that we have Ethereum main chain and some proof of authority chain, and we could basically send real ether to this proof of authority chain and then transfer this ether between users of the proof of authority chain in a secure way. So what are the challenges that we have? So there are main three: security, finality, and cost. So security, basically how to relay those messages in a secure way, so no one can modify the data that is being relayed. Finality, so how to handle change organizations, how do we handle it now, and how we'll handle it in the future. And cost, so how to minimize the cost of those interchain transactions. And maybe I'll mention one more thing about the bridge, so not to confuse you. So with Polkadot, we have this concept of parachains. These are blockchains which natively support Polkadot. And the bridge is a different thing, slightly different thing. So the bridge will allow existing blockchains plug in to the Polkadot network. So blockchains like Bitcoin, blockchains like Ethereum, in Parity Tech we already implemented both of them. Yeah, so let's get back to the presentation. So these are our assumptions. For now, assumptions with which we've already built our existing bridge. So we have we gave names to those two of those chains. So there's a home bridge, and a home bridge is a chain with a real value. You can think of it you can think that it is an Ethereum main chain, and there's a foreign chain, which is a proof of authority chain. It may be an open proof of authority chain like Coven, but it may be also some kind of private consortium blockchain or whatever. Foreign chain is a proof of authority chain, and foreign chain authorities are responsible for relaying the transactions. So what we basically do, we create those so normally in proof of authority chain you have a blockchain and the authorities which are responsible for issuing new blocks. And we take this approach one step further, and we say that those authorities not only have to issue new blocks, but they are also responsible for relaying the transactions from the home chain. It's pretty simple here. So we can see that there is a transaction coming to the smart contract on the home chain. This transaction has a real ether. This ether is being locked on the main chain. There are multiple authorities running bridge software. They are looking, they are watching this smart contract, and whenever there is an event created, the event that which says that something needs to be relayed to the foreign chain, those authorities are relaying this message to the foreign chain, and the end message which is being relayed by authority triggers the state change. So over here we can have something like ERC20 tokens, and this token its value is basically equal and represents the token on the home chain. How secure is it? So basically, security is guaranteed by trustworthy authorities. If we trust those proof of authority chain that is secure, our relay is also secure, and we can say that actually the security of this bridge is equal to the security of the foreign chain. But can we improve it? Yes. So the answer is yes. In Polkadot, Rob already mentioned that there are fishermen. So we can imagine that in Polkadot network we'll have fishermen also watching those authorities relaying information from foreign chains and punishing authorities who are not relaying the messages in time, because that's basically the main risk. Now let's talk about the finality. So maybe some of you know, maybe some of you don't, but basically blockchain constantly forks. And what happens, we have, let's say, block number 5 and block number 6, then there's 7a, then some other mine 7b, then there's 8a, 8b, and 9. And what happens, basically after 8a is mined, we are still on the, let's say, top chain, and after 9 is mined, we have to reorganize the head of the chain back to the new best head. And how can we handle that in the bridge? So we can either wait for something called X blocks finality. That's what exchanges are doing right now. So they're waiting for a certain number of confirmations, certain number of blocks that which needs to be mined to consider some event final. Or with Polkadot, we can also the fisherman can be responsible for watching the authorities and seeing if authorities are actually relaying the information about chain reorganization back to the Polkadot network. So yeah, these are two approaches that we can make. Now let's talk about this, like how the transactions from the parachain to home chain works. It's slightly different. I will just go back to the home chain parachain. So this graph we've already seen. There are authorities in the middle, and they are just relaying the transactions over here. We could do the same thing with transactions from parachain to the home chain, but this would make those transactions. This would require a lot of transactions on the main chain, and those transactions are actually quite expensive. If you're thinking about Bitcoin transactions, one transaction costs approximately a few dollars. So relaying a single transaction back to the home chain would require us to spend X times a few dollars. So it's way too expensive. So what we do currently, we have those authority nodes, the parachain on the left side, and whenever someone wants to withdraw the money from the parachain and send it back to the main chain, he sends a transaction which creates withdrawal event. So basically the same as with the transaction from the other side. And then this transaction, so the authorities are watching for this transaction. Whenever they see it, they don't relay it directly to the main chain, but they submit the confirmation that this transaction occurred to the smart contract, and this submission contains their signature. So we can say that we have some kind of signatures collector on the parachain, and then an authority who submits those signatures to the parachain is responsible for relaying this transaction to the home chain. And again, if we have fishermen, the fisherman can punish and watch if the transaction was actually relayed by one of the authorities, and if it's not, it can punish this authority. And yeah, so on the home chain, the only thing that we do is we actually just verify that the signatures in this transaction, which was relayed, if those signatures are correct. Yeah, so that's basically how we minimize the cost of those transactions. So home chain to parachain transactions are free from the perspective of the bridge, because the parachain transactions cost nothing in terms of gas price, in terms of transaction price. Collecting signatures is free, so because it happens on the parachain. And parachain transactions are collected in the single transaction before submitting to the home chain. So what we do now, we can collect all transactions that happen in a single block on the parachain, sign them together, make those authorities sign on them together, and then one of the authorities is responsible for relaying all of them together to the main chain. So the overall cost of like relaying the transaction from the perspective of the bridge, from the perspective of the authority, is always equal to sending one transaction, at most one transaction per block. So it's very low. So now let's talk about use cases. So here on the middle we could have Polkadot network. On the left there's a user. Here we can think about of it as some kind of bank, consortium bank blockchain. So there are multiple banks connected to a single chain and are multiple authority providers, and they basically they're responsible in this diagram is verifying the customer. So they have some kind of KYC service, and they not necessarily want to expose the data in this blockchain, but they are connected to Polkadot network. And here we can have a melon port, parachain. Melon port is one of our partners. Is software for asset management. So in our use case, we can think that there's a user, and user wants to purchase some assets on Melonport platform, but the user needs to be verified. He needs to go through KYC. So he sends a transaction to Polkadot network, and the transaction says that I want to purchase those tokens, and purchasing those tokens require verifying on KYC. So the transactions go over here. Here there's a request to Melonport to KYC chain. So it goes back through Polkadot network to KYC chain. The KYC verifies this user, send transaction back to Melonport bridge. The purchase happens, and then the funds are securely stored and associated to, let's say, user's Ethereum address or something like this. So that's just one use case which is relatively simple. And yeah, there are many others possible. And that's basically it. That's basically how it works right now. Thank you.
Let's take a 10-minute break. We will resume at 8:35.
Okay, if there are any questions, I'm also happy to answer them.
How about other bridge like Bitcoin or some kind of that? Different blockchain without smart contract.
Okay, so all bridges will be developed separately, and their functionality will be limited to the functionality of the blockchain that this bridge is built for. So even right now with Ethereum, we have a bridge that allows us only to transfer Ethereum tokens between the bridge and between the home chain and the foreign chain. And we could build exactly the same bridge for Bitcoin, but what we couldn't build for Bitcoin, we couldn't build a bridge that transfer arbitrary messages between chains, because in Bitcoin for Bitcoin doesn't make that much sense. So those bridges will be just limited. They will have limited functionality based on the currency that are based on the blockchain they are connected to. Okay, here. Sorry, just had coffee before coming here. Thanks for
It's
inside Foundation. So just wanted to Yes, you can think of it as a
Oh, hello. Event is about to begin.
People just like shirt with the others and then.
So for our next speaker, we have Web3 to tell us more about Web3 Foundation. The presentation will be fairly short. So we're going to have a longer Q&A section after this. So during the Q&A section, you can ask everything about Polkadot, Web3, tech, or whatever, exclude the sale, everything. Right.
Hello, my name is Genevieve Renoir, and I'm here with the Web3 Foundation, and Parity as well. We just heard a little bit about Polkadot, but I'm going to tell you a little bit more about why we exist and a little bit more about our relationship. So the Web3 Foundation is headquartered in Switzerland, and we are committed to decentralizing the web. And we're working with Parity Technologies to build Polkadot. So you heard a lot about the Polkadot technology just now, but I'm going to tell you a little bit more about our vision for Web3. So right now, the web is somewhat centralized. There are a few large companies, entities, people with a disproportionate amount of responsibility and control and power. So if we could find a way to create an alternative where we could have control over our data, control over our transactions, and a way to interact with each other without having to trust a third party or become vulnerable to certain exploitations, then I think that would be very valuable. And so Polkadot will be a huge part of that. But Web3 is no single company, foundation, entity, or project. We want to make sure that anybody who wants to build a decentralized application or a protocol or any kind of technology that would be helpful for this vision of Web3 has a way to do that. So please get in touch and let me know if that's something you're interested in. So you can see here we have a mission statement. Again, I won't read it to you, but basically, if you would like to be a part of it, I'm here to help with that. And yeah, that's pretty much it. So I think that we can start our Q&A. And I mean, I can go on and on about why we should decentralize the web, but I think that I'll do that maybe in the future sometime. So yeah, that's pretty much it.
Okay.
Hello, Web3.Foundation. So I'll have Robert and Marek come back up so we can answer a few questions.
I got a question. I wasn't really listening to every details on your really quick speech, but what is the mission, you think? Yeah, of
It's right there.
Okay, yes. So you agree anything? I mean, well, I just wanted to listen to your words about the mission. Yes.
Okay, so the Web3 Foundation nurtures and stewards. So by nurturing, we provide resources in terms of financial resources, technical development resources. We organize communities. We want to bring people together to nurture and steward. And by stewarding, again, that's an idea that we provide this expertise or these connections to other projects in order to help guide the ones that we feel are the best suited to succeed. technologies and applications. So that's that idea about protocols or decentralized applications. In the fields of decentralized web software protocols, particularly those which utilize modern cryptographic methods to safeguard decentralization to the benefit and for the stability of the Web3 ecosystem.
Okay, so how do you did you ever have another project besides Polkadot?
Polkadot's our first project. So Web3 Foundation is new, and we were just coming into existence this summer.
Maybe I'll try to answer this question a bit further. So Polkadot is this key component of something we call Web3, and Web3 is part of it's a vision mostly created by Gavut, but also other people in decentralized space, and it's about having those decentralized applications that could talk with each other, interact, and we need a few key components to achieve that. So we need some kind of a blockchain, so trustless communication on top of the blockchain, actually trustless interaction. Then we need some kind of a storage layer, so maybe something like IPFS, maybe something like a safe network, something where we could store, maybe BitTorrent, something where we could store files and large files, and also something like, Whisper, some instant messaging protocol. Right now our focus is mostly on Polkadot, but we are also looking at other areas. Probably for decentralized storage, we'll be collaborating with protocol labs on IPFS, and that's basically that.
Is Web3 JavaScript library related to Web3 Foundation?
Okay, okay, kind of. As I said before, Web3 is this concept created by Keynote, and he, back in the day, when he was CTO of Ethereum Foundation, he already wanted to implement that when he was like a CTO of Ethereum Foundation. And actually, I was building this Web3.js library early on. But how it was created was basically us adding another methods to this kind of simple and very basic JavaScript library that never meant to be a production-ready library, but somehow developers started build on top of it, and right now we have, it has probably 1,500 stars on GitHub or more, and there are thousands of people using it, but it was never meant to be, not in current form, to be, like a bare bone for Web3 internet. It's just a name. Unfortunate for this JavaScript library.
Okay.
So how do you decide which project to found? Yes.
So we tried to found Polkadot was, I guess, that one. But the other ones that we would like to support, we're going to have a committee, and that'll be done by humans at first. But eventually, we'd like to have a decentralized, autonomous way of doing that. So that would be through different criteria, and something that's a little bit more formalized, so that we would be able to make judgments about which ones will be the most useful. And so on the Polkadot network itself, and then as the Web3 Foundation, we are moving towards that.
Is there any kind of people that do research?
Yeah.
And so, do they have to turn any application, that kind of thing?
Yeah. Right now there isn't a formal application with specific fields, but if you send an email to hello@web3.foundation, we monitor that and we review it regularly, and then we tend to reach out to anybody. Actually, we respond to everybody, but we reach out when somebody has something that's really interesting and that we want to become a little bit more involved with.
So how would you cooperate with those teams? For example, if there's a team that's doing something really cool, so they reach you, and then how is the cooperation going to work?
So if they want something that is specifically related to Polkadot, then they would get in touch with hello@web3.foundation, and that would go to either Robert Habermeier or Peter Chabin, and then we could figure out how we can kind of develop in parallel and make sure that there's something that is going to be useful now and in the future. And if something that's a little bit different, then that would go probably to Gavin himself and others to think through. And then once we decide that we want to support, we provide financial resources or other development resources and eventually we'll be able to include them in some of our more community-focused events, and that would be a good way to support these projects. And open to other ideas as well, of course.
Sounds flexible.
It's very flexible. I mean, we're very new, and
there's no standard procedure for doing these things.
no, we don't have one yet. I think that this is an opportunity to find out what works best, and to be really agile and really flexible, and to be able to respond to different conditions and different ideas.
And do you fly to another countries often?
Not that often.
In Asia,
Well, Asia is extremely important to us, and so we're really happy to be here in Taipei, and so thank you again for having us and organizing. And we want to make sure that, yeah, thank you. And we want to make sure that we come often, and so that we have this time to have face-to-face contact, and that we have a presence here, and that if anybody ever wants to come to Berlin, or Switzerland, or London, we want to make sure that we're there and that we can spend time together.
I got a quick question. Do you have like a CEO of sorts, or is there like one person who is running the ship? Because you've got a lot of moving parts in this.
It's decentralized.
It's essentially.
Decentralized leader, I like it.
I think the easy answer to the question is Gavin Wood. He is, yeah, exactly. He's the chairman of the foundation, president of the council, founder of Parity, and yeah, so Gavin is obviously incredibly brilliant, and we're lucky to have him at the head of all of this.
Cool, thank you.
So, you said you provide startups with financial resources. What is, I guess, your financial resources from? Is it investors or other nonprofit foundations, governments?
Yeah, I talk about the resources that Web3 provides in terms of financial as well as other supportive. But we were responsible for the Polkadot sale, and so that's where many of the financial resources came from for the private and public contributions financially.
So Web3 is actually a nonprofit.
Yes, Web3 is a nonprofit foundation. Polkadot is
profit or nonprofit? The company?
Neither. Well, it's nonprofit. Polkadot will be released into the public as open source.
So it's nonprofit?
Nobody's in charge of Polkadot. So the Web3 Foundation has collected the resources to build Polkadot, to bring it to its existence. Okay. And we're working with these developers and other people at Parity Technologies, and together we are bringing Polkadot into existence. And once the Genesis block happens, once the network is live, it will become owned by the public. We will not have any control over it.
Yeah. It's just open source.
It's open source,
exactly.
exactly.
It's open source. So actually, historically at Parity, we built at Parity. We've been working for almost 2 years now. I think in a couple of weeks it'll be 2 years on Parity Ethereum. We have lots of projects. It's all open source. Please check out the GitHub page if you don't believe me. We got it there.
But Parity is
yeah. So Parity is a for-profit venture capital funded startup.
Got it.
Working on building like blockchain core technology and things like that. So we have like a very well-established team, veterans in the space, people who are familiar with implementation details as well as abstract ideas and the understanding of the processes.
You're going to check the link on the Polkadot website. If I click the code button, that directs me to Parity. So is there any open source Polkadot code?
So, I mean, as I mentioned before, even though if you download and run that Parity client, it is an Ethereum node. As I explained, we have, in the internal architecture, it is like this abstract blockchain node. So essentially you have plug in something that fulfills the definition of a consensus engine and something that fulfills the definition of a state machine, and it can run that. So right now that's where the development has happened so far because we already had this code. But soon we'll be branching off into other repositories that are specifically for the implementation of Polkadot, as well as open source modeling, proofs of concept, etc. That will also live in their own repositories.
Okay, so now it sounds like it's integrated into the Parity project, right? So
for now, yes, but I think, of course, in the end, it would be its own executable, so it doesn't carry around all the Ethereum code as well. It doesn't make much sense. But we would, right now, it's been a good launching off point for playing with some ideas that we've had.
Okay, thanks.
Do you have a schedule or timeline?
Yeah, so the timeline is fairly conservative at 2 years. So essentially, in the next couple months, we want to get out the first proof of concept, like basically In a few weeks, we're just gonna basically disappear off the map into some small village and just do nothing but grind out this proof of concept. But then there's also other key infrastructure components like bridges between other blockchains, working at message formats, releasing papers on things like economic incentives of proof of stake or sharding or what have you. We expect that this will take about 2 years, but it could come faster.
Could you talk something about Polkadot ICO and the relationship between the company and the
Yeah, so we're not really going to focus on that today, but just to summarize in short, the Web3 Foundation has undertaken the responsibility to develop Polkadot, and so we were responsible for the sale, and so we collected the resources as the Web3 Foundation, and then we will deploy that capital and other things to people working on Polkadot and other technologies as well. But we can talk more about that after. Any other questions?
Okay, let's thanks the Polkadot and the Web3 Foundation again. We'll be there for a while, so you can go to here and discuss with us. And thank you.
Thank you for having us.
Thank you. Thank you.
场地到几点都大家可以9点半。场地到9点半，都是大家 free。我觉得就是全部。我是这样够了。
Hello. The venue will be closed around 9:30, so please be gone before 9:30 so we can help the venue be closed.